Welcome all of you to this video. Today in this video, we will understand the angle sum property of a quadrilateral. Here are some figures that you must recognize. These are all quadrilaterals. Now the question is, what is the meaning of quadrilateral and what is it? Figures that have four sides are called quadrilaterals. Like here, all these shapes have four sides. Now can you tell how many angles are there in a quadrilateral? Yes, a quadrilateral has 4 angles. All the angles are shown in the figure. Look at this quadrilateral. We have named all the vertices and angles. Can you tell the sum of all interior angles of this quadrilateral? Let us take the help of an activity for this. With a piece of cardboard, we make a similar quadrilateral and cut its angles in this way. Put the vertices of all these angles at one point. Then we can see that they form a circle. We know that the angle formed at the center of the circle is 360 degrees. Therefore, based on this activity, we can say that the sum of interior angles of a quadrilateral is 360 degrees. Let's look at verification in its mathematical form. We draw a diagonal which divides the quadrilateral into 2 triangles. For example, we have joined AC. This quadrilateral is now divided into 2 triangles, ADC and triangle ABC. As you can see that angle A is divided into angle 1 and angle 2. Angle C is divided into angle 3 and angle 4. Let us write the angles as follows. With the help of triangle sum property, we can say that the sum of the angles of each triangle, triangle ADC and triangle ABC, will be 180 degrees. Because we have divided the quadrilateral into 2 triangles, therefore, we can say that the sum of the 4 angles of the quadrilateral will be equal to the sum of the angles of the 2 triangles. So we add equations 3 and 4, from which we get the sum of all angles at 360 degrees. With the help of equations 1 and 2, we can write equation 5 as follows. In this way, we get 360 degrees of sum of all 4 angles of the quadrilateral. We also call it the angle sum property of a quadrilateral. This property is true for both convex and concave quadrilateral. Therefore, we can say that the sum of the 4 interior angles of any quadrilateral will always be 360 degrees. Today in this video, we learned about the angle sum property of quadrilateral. In the next video, we will see some examples based on these. Welcome all of you to this video. In the previous video, we understood the angle sum property of the quadrilateral. Today, we will see an example based on this. In the polygons shown, the ratio in the angles B, C and D is 2:3:4 respectively. Find the measure of the smallest angle of the polygon. We can see that this figure has 4 sides: AB, BC, CD and DA. So it is a quadrilateral. In the given figure ABCD, the angle A is 90 degrees. In the polygons shown, the ratio in the angles B, C and D is 2:3:4 respectively. Suppose X is the greatest common factor in the measurement of angles B, C, D, so we can say that angle B will be equal to 2x, angle C 3x and angle D 4x. As we know that the sum of the 4 angles of a quadrilateral is 360 degrees, which we can represent as a linear equation of this 4. Substituting all the values into it and further solving gives us a measure of x by 30 degrees, using which we can find measurements of all unknown angles in this way. As you can see, angle B is the smallest angle of the polygon, which is 60 degrees. Let us see another example. If the 4 angles of a quadrilateral are 3x plus 2 degrees, x minus 3, 2x plus 1 degree, 4x plus 10 degree respectively, can you find the measure of x? We know that the sum of the 4 interior angles of a quadrilateral is 360 degrees. So 3x plus 2 plus x minus 3 plus 2x plus 1 plus 4x plus 10 is equal to 360 degrees, which we can write in this way. Solving the equation further gives us a measure of x 35 degrees. Can you tell the sum of all the angles of a pentagon? Try it yourself. We will see the solution in the next video. Today in this video, we saw examples based on angle sum property of quadrilateral. Welcome all of you to this video. In the previous video, we saw examples based on the angle sum property of a quadrilateral. Today in this video, we will learn to find the sum of the angles of polygons. Can you tell the sum of the angles of the shown figures? The first shape is a triangle. The sum of all its angles is 180 degrees. The second figure is a quadrilateral, and in the previous video, we have learnt that the sum of the 4 angles of a quadrilateral is 360 degrees. Can you now tell the sum of the interior angles of these figures? Let's try with the help of an activity. Let's start with this pentagon. You may remember that we have found the sum of all the angles of the quadrilateral by dividing the quadrilateral into 2 triangles. In the same way, we can also divide the pentagon into triangles. If we draw a diagonal from any vertex of the pentagon, say M, then this pentagon is divided into 3 triangles. And we know that the sum of all the angles of a triangle is 180 degrees. If we add the sum of the angles of the 3 triangles, then we get the sum of the interior angles of the pentagon, which is 540 degrees. Therefore, we can say that the sum of all the angles of a 5-sided polygon is 540 degrees. In the same way, we can divide the hexagon, heptagon and octagon into triangles and find the sum of their angles. You can see that by making the diagonal, we have 4 triangles in the hexagon, 5 in the heptagon. 6 triangles are found in an octagon. When we multiply the number of triangles in polygons and the sum of the interior angles of a triangle, the sum of all the interior angles of that polygon is found. On this basis, we can say that the sum of all the interior angles of a polygon is equal to the number of triangles formed by making a diagonal from one vertex of that polygon and the product of 180 degrees. Let us fill this table. Looking at this table, we see that the number of triangles formed in each polygon is 2 less than the number of sides of the polygon. With the help of this table, we get this formula for the sum of all interior angles with n sides, where n is the number of sides in a polygon. Today in this video, we learned to find the sum of interior angles of a n-sided polygon.